Hello, everybody. ODAT Nerd here, aka Terrence. This is the pre-recorded video that is going to play at the start of every Devember video. So, what day is it? If you're watching this on the day that I recorded it, probably a day in December. What day? I don't know. I'm not creating 31 of these things. This is to tell you that we are working on the Devember project, which is a remote build system in Sublime Text. Now, down in the description, if I have done my job correctly, there should be a link to the playlist that has all of the videos in this series, which starts with the video that describes what the heck it is we're actually trying to build here. And this video will be a minimum of an hour long. I don't know how long it's going to go because I haven't recorded it yet. It's still November right now while I'm reading this to you out of my brain. It's not actually written down anywhere. I think that's probably easy to tell. I'm not very good at talking off the top of my head into a camera. So, what are we going to be doing tonight? Don't know. Hopefully, working on something really interesting, though. Probably should have thought that through a little bit more. In any case, we're going to go ahead and say the following. If you like these videos and you want to know when there's going to be more of them, subscribe to the channel, link in the description. If you're interested in videos that aren't live in nature, there's another channel I have that is going to be providing those. I have in the past and I will again. I'm just not right now because I'm doing this every day for December and it's taking up all my free time. Link to that is in the description. Like any videos that you find useful, comment on any videos if you have any questions, and most importantly, have a good time. So let's go ahead and give it to myself in the present, if you will, to continue on faceless because I don't have the sort of setup that allows me to stream my face while I'm working. Hello, everybody, and welcome to Devember Day 10. And what sort of fun can we get up to tonight? Well, I spent after I checked things in last night and dropped into a minor coma. Coffee had no effect on that, which is why I appear to have become habituated to drinking coffee while I'm doing these streams at night, and as such, I am having one right now that is flavored like a cinnamon bun. I highly recommend. But this today, pretty busy day at work. I have some vacation time coming up in a little while, and things are reaching a fever pitch. So I didn't get a lot of time to look into things, but what I did investigate, and this is probably one of several pages that I may have come up with whilst doing that, was the notion of how exactly asynchronous things like we're doing here work in C sharp. And as best as I've been able to determine, when you do one of these begin type operations, this is in the background creating a task, as I understand it, that is being selected by one of the threads from the thread pool, possibly. Maybe there's some other thing that could also happen if it was in a GUI app. But I guess it's probably safe to assume that this is happening in some external thread. This callback then thus gets called in a different thread, and maybe that makes us happy and maybe it makes us sad. I'm more willing to bet that it makes us sad than anything else. But um, that's going to inform what we're doing tonight, which is to try to finish creating core networking so that the Python client can talk to the .NET server. And what we really just need it to do at this point is be able to receive messages from the other end and send messages to the other end. And if you watch the ridiculously long live stream where I had a stupid mistake and spent a while trying to debug it, you know that we totally have receiving messages from the other side all nicely laid out, and now it's time to do sending. And I set this, I'm gonna say I sent this to the side. I set this to the side and wanted to do reading first, because of this whole how exactly threaded is this. And the reason for that is I'm envisioning that what we need here is some sort of queue type operation, which is why I have concurrent queue thrown up here as something that we can do. Now, it's a thread safe first in, first out type queue, and the comments at the bottom of this ridiculously long web page, if this is the one I remember reading, says all public and protected members are thread safe and may be used concurrently from multiple threads. Because it seems to me that what we want to do is in this read callback, if we decided that we wanted to send a message, we should drop it into a send queue of some sort. And then other code would be responsible for pulling items out of that queue and writing them across. Now, this is sort of stymied by the fact that when we read, we just always want to be reading all the time. So no matter what we do in the read callback, we always fire up and begin reading at the end to make sure that we start reading more data. And that's obviously just going to hang until the connection closes or more data actually becomes available. I'm also led to believe that if these aren't using threads, and again, C# is one of those confusing topics where maybe the fact that there are several versions of .NET, plus there's .NET Core, which is similar to but different from, but the same as but not the same as in weird, mysterious ways. It's really hard sometimes to, if you're a newcomer, read something and actually know if you're interpreting it in the correct context or not. Because one thing I read seemed to indicate that doing this begin whatever is going to split a task off and handle it in a thread from the thread pool. But something else said that no, a thread's not sitting waiting to do that. It's actually just IO bound waiting for something to happen. Unless you're in a GUI application in which there's some other kind of context that causes it to do a different thing in a different place. And at that point, my head exploded. Like Crichton when Lister wanted to put brown sauce on the lobster, if you happen to be a Red Dwarf fan. So the thought occurs that there could be potential issues here because what we don't want to just print the message and then create a new one. We want to queue the message that we created for transmission to the other side in this particular case. Now, we don't always want to do that. We may want to actually have some processing somewhere else. But the fact remains that if it's possible that the send happens in a thread, how do we lay this out? Because here's the theory. When we do a read, no matter what we do, we always call begin reading. We always want to be reading. Writing, on the other hand, we don't always want to be waiting for writing because unless the socket buffer is full, you're always able to write. And if you don't actually have anything to put in there, you're going to just use 100% of the CPU checking. Is it time yet? Is it time yet? Is it time yet? Are we going to Def Gardens? Are we there yet? Are we there yet? It's a horrible, horrible thing. That's obviously not what you want. So just thinking about that, that must mean that the send callback needs to be able to send as much data as it can, and then if it thinks it still has more to send, then it should do another begin send type operation to start another async loop, which will, I presume, happen when the data we will get called back when the send has actually completed. And if that's the case, what happens if while we're sending, someone wants to put something else into the queue? Does this mean we have to track when we're sending something so that if you try to put something in the queue, then that code is going to have to say, if I'm not sending something, then start sending. But if I am sending, then do nothing. Because you don't want to kick off, I presume you don't want to kick off another write operation while one is already in progress. Because if it's using threads, it might use a second thread to do the same thing, and there'll be two threads racing to complete something from the same buffer, and that is almost certainly a recipe for someone to go bald after they pull all of the hair out of their head. So I'm guessing that what we need is first for this to just drop messages into a queue somehow. That code needs to know if it's sending or not and only begin a send operation if it isn't already sending. and a running send operation will spawn a new one whenever it actually finishes if it thinks it still has more data. Now, if the send code can guarantee that it's the only one taking things out of the queue, that's probably pretty good, because then we can be assured that as long as we think the queue has some data in it, then it's probably okay. We do the same thing in the client code. Um, so what I want to do is get that echo going first. And again, this is probably not architected as great as it could be. Um, we could, in fact, try to make this even dumber by just having it only send one at a time, but that will get in trouble when we test it later, because our Python network code can just shoot two messages in a row. And what if it's still processing one when it gets the other? So we want to just get it to a state where it can send messages one way and send another message back, because until we get into the project proper where we actually determine what this server has to do and how it's going to be structured to be able to do that, it doesn't make a lot of sense to try and do this, at least for me, because I haven't done it enough times. For the network code in the Python, that's similar enough to something I've done a lot of times in the past in various projects in various ways that it seemed like that is something that could happen. And once we get this part running, if there's still time left, I want to modify the messages.py in here and protocol messages here. And that might actually be something we have to do first here in this end, so that when it encodes a message, it encodes the length of the operation into its buffer directly. Because I'm thinking that when we transmit data, we want to do it the same way as we do here in the Python code. And that would be like so. When we actually call the send thing here, we encode the message. Now here we're creating a new byte array that's the length of that one plus 4, and packing this extra stuff into it and then transmitting it by just putting the whole block, because we have to send that 4-byte prefix and then the rest of the stuff. It's a lot easier. As you see, when we do reading, you need to read enough bytes to get 4 bytes first, and make sure you have exactly 4 before you can decode them to figure out how much more data there is. It's a lot nicer to send, to just say, here's a buffer full of, here's a array full of data. When you've finished sending it, you've finished sending the message. So we want to actually, I think it makes sense to make the partial messages here and the messages here encode messages to have the size on them directly. So this code here would just be send queue put protocol message instance dot encode, and that would be like the single one line that you need. And we want to do the same thing over here. Um, and that sort of gets into tricky territory, because we want it to do that when we're sending, but we don't want it to do that when we're receiving, because we want to receive those first 4 bytes and then know how much the data is. And that we don't, until we get those first 4 bytes, we don't know how much data there is, so we can pre-allocate a nice sized buffer for things. Now, of course, there could also be some optimization here in protocol message, and also in partial message. I guess I was thinking more specifically of partial message, because of the read code, every time it reads something, just creates a new instance, which means it's always creating byte arrays. This could actually be smart enough to have a sentinel that knows whether or not it's got the body, instead of using null. And this byte array could be allocated to the size of the first message that happens. And then when you could call like partial message reset instead of creating a new one. And that would reset the flag. And then the next time it comes through, it could use the same array as last time or create a new one. But that adds extra complications into things that we perhaps don't want to jump into. So I think maybe we will modify the encode of these methods to work the same as it does sort of over here. Actually, maybe we should modify well, no, the client is still going to send the correct data. That's an easy enough change to make there. It's probably a little trickier here, especially since this looks so, as one might say, but ugly. Now we are in the remote build server. What if I was to create a new thing here and call it messages? Okay, now what I want to do here is, okay, this partial message is in a file all its own, right? So I want to move that into the oops, messages folder, like so. And I'm also going to move this. I don't know if there's a, I cannot move this into the messages folder, like so, because those are two things that it'll make the code nicer to look at here. And then particularly, partial message is already um, good to go in this regard. And I think we may want to make the factory be here and then the introduction message and the error message be their own things, just to make this a little nicer to look at, is my thinking. So I might oops, rename this file to, instead of protocol messages, we might call it protocol message factory, like so. And then we might save as this as introduction and save as it again as error. So there's all in that location. Now, if we were the error code, then what all we need here is this code for that message. And if we were the introduction message, then all we need is this class. We'll add 2 there because we seem to be putting 2 everywhere else, but we don't need this any longer. And if we were message factory, like so, then we want that, and we want that, and we want message factory, but we don't want introduction message or error message. Thusly, and again, we'll throw another one in there because that seems to be what we're doing. And save. Now, if I clean and build, we're still having things work the way we want. So let us say that we do what? Oh, that's the one we want, excuse me. We're going to stage the deletion of partial messages and stage the deletion of protocol messages, and then add that and that and that and that. So those are all staged. So we might actually note in this case that we renamed one file into a new place. Protocol message became protocol message factory, so it's just new and it's different enough that it can't tell, and those split out. So we could say split the server message code into separate files. For clarity purposes, this splits the various parts, the various classes in the message system of the server into separate files, one class per file in a new subdirectory to make the code easier to manage. And we might also do a little something like, if we named that protocol message factory, maybe this should be named as well. And here in this file, and here in this file, and here in this file. If there is one thing that I miss about using IntelliJ and other JetBrains tools, it's that their language comprehension is cool enough to make renaming things a little easier. But one nice thing does not a good product make. And although I liked it for a while, after using it enough times, I found that I was hardly ever using 99% of the features that those tools have, and that remaining 1%, most of the stuff I was doing ended up not doing exactly what I wanted. I was constantly found myself reformatting my code. So why use something that can reformat my code if I have to reformat it myself manually? I reported lots and lots of bugs, and in the end, I decided to move to Sublime, and I've been pretty happy with it ever since. Sort of a little conversation that was happening in the unofficial Sublime Text Discord. Um, whether various tools are usable or not and how configurable they need to be. And I agree that I would like more configurability in a lot of things, including Sublime. Like I'd like to be able to split the console out. Maybe it would be handy in rare situations to have this panel over on the right side or the left or something. I don't know why anybody. I wouldn't personally be interested in having the sidebar on the right, but I'm not opposed to that if people want to do it. But at what level, when you're adding features to things, do you end up trying to please everybody and end up pleasing no one in return? I'm going to do a full clean just to make sure. But that seems like it is doing what we want. And I'm going to run it again. And I think, oh yeah, we totally need a terminal, don't we? Nah, I'm not going to use that terminal. I will use this terminal emulator. Go to local source, Devember 2018, net test, and Python 3 up network.py. We got messages. Things are still working. And away we go. So perfect. We're just going to jump in here real quick, stage all of those files, and amend the previous commit. Because we split it into files that should have been part of that, but I like to do those sorts of things in separate commits, or in separate operations, but inside of the same commit. So what did we want to do here? We don't really care about the protocol message factory per se at the moment, but an introduction message, when it encodes, it doesn't want 3, it wants, now how big is that size? It's a 4 bytes, right? So we want that to be, let's go ahead and zoom that. For an introduction message, we want to encode to 3 bytes, which is 2 for the message type plus 1 for the protocol version. And what we actually want is then another 4 on top. So 4 and 3 is 7. So I might actually do it like that. And block copy introduction. The source is the bytes. Hang on. Protocol message factory converter get bytes. So this is the source array. We're getting at that position 0. We're putting it in message. We're actually putting it at index 4 now, because the first 3 bytes are going to be the length, which we're going to toss in just a second. And then if that's the case, then it goes 0, 1, 2, 3, 4, 5, and this goes at position 6 because there are 7 things numbered 0 to 6. I probably thought about that more than I needed to. Buffer dot block copy, and again we'll say protocol message factory dot converter dot get bytes for uint32, the value of 3 at from position 0 at position 0 for 4 bytes, which I think should do what we want. Now, of course, this could be way better. Oh, did I short it? I might have shorted it. From there to there is the call to get bytes. Source array, source position. Oh, I forgot the destination array at position 0 for 4 bytes. And then the next thing happens at 4 for 2 bytes. 4 and 2 is 6. There's that one. Whoops. If I do it this way instead of typing a B, it'll actually build, but I'll have to do it again because I think there was a warning in the console there. Thusly, it happens fairly often. And that is the introduction message, probably encoding the way we expect. We're going to save off on actually committing that until we know that it works, of course. Now here, this one's going to be a little more of a but. So we want, again, 4 bytes plus 2 bytes for the message type plus 4 bytes. Oh, how does this one work again? 4 bytes for the message length, 2 bytes to know that, oh yeah, that's right, 2 bytes to know that this is an error message, 4 bytes for the error code, 4 bytes for the length of string, and then the length of string. So we might actually pull this line from here. The uint to the actual length here is going to be what? It's going to be 2, well, actually, it's going to be message.length minus 4 is what it's going to be. Because whatever this array is was big enough to hold the entire message, now it's big enough to hold the entire message plus 4 bytes for this size. So we're going to do that. So it goes into that buffer at position 0 for 4. Now this one goes into position 4 for 2, which means this one goes into position 6 for 4, which means this one goes into position 10 for 4, which means this goes into position 14 for that, and that should be good enough. Now comes the scary part, if you will. Let's assume we can close those for the time being. I think we need to close and reopen that to get gutter to pretend that it knows what it is. If we actually even need that one, I'm going to close that for the time being. So we're looking at build client. Now, let's again think of how exactly we want this to work after I take a sip of cinnamon bun flavored coffee. To tell the truth, it actually tastes more like the frosting on a cinnamon bun than a cinnamon bun. But that's good enough. There's a little bit of cinnamon taste in there too. Sometimes I use a chocolatey milk flavored thing in there instead. So this is the client. Now let's say one of the things we want here is a concurrent queue. So we might say concurrent queue of type iProtocol message, I guess, because that's what that thing returns, right? Out queue, and it's equal to new concurrent queue I protocol message. How about that? Again with the OS9. Okay. Type or name of concurrent queue could not be found. Now, system.collections. Thus, error no 9. Boy, that's happening more and more here. One error. Did I spell it wrong? Is that not? Did I spell it wrong there? Do I not know how these things work? No, it's spelled right. Well, where's it? Is there an example? Concurrent queue, the type that equals new. Boop, boop. Well, I don't know. That really seems like it should work like a hot damn, to be perfectly honest. Oh, I guess I need a dot concurrent on the end of here. All right. Was that outlined here? Oh, yeah, I guess it was. My bad. There we go. Okay, so that's okay. This is going to be what? The send buffer gets assigned when we receive a complete message, tracks the bytes to send the bytes. So we actually already have that thing that we need there. So what we have here is, whoops. Hey, there we go. The queue of messages that should be transmitted to the remote end of the connection. Now, here's the thing. We know that send buffer is set up by begin sending, and send callback looks inside it. What actually calls begin sending? Well, actually, we could probably do here, because we have the client, right? Client dot out queue dot, what's it called in this? Put in queue. We don't need to say we read it. So that's one part of that operation. We have queued it. Now, I think we don't actually want to do that per se. This is the code that used to send things. We used to say the send buffer is get bytes, and we've sent none, and begin sending. We took that other part out. And then when you call begin sending, it does that. When it's done, it calls send callback, and send callback does begin sending if it has sent all the data. Now, another thing here is that it used to close the connection, which is not what we want to do. So we're going to need to fix that too. So here's how we are going to work this up. There's begin sending, there's begin reading. We're going to say, up here, let's say, public send I protocol message, which is going to be a, whoops, need 3 of those. Queue up the given message for sending to the remote end of this client connection. And actually what we would do in that case is copy that line and say client.send message. And this part goes here. So when we try to send it, we try to queue it. And then we can say if client.sendBuffer is equal to null, then we need to do some sort of magic. So what would we actually do? I guess we would say client.sendBuffer is equal to, oh yeah. We only want, let's do it this way. We only want to kick it off when you enqueue something and the client send buffer is null. So we need to change this part a little bit too. Begin sending needs to be responsible for setting up send buffer and that, let's say. So we're going to say if the send buffer is null, then client, no, we can't say client out queue. This already is the client. What the copy paste error. If the send buffer is none, then begin sending like so. So when you tell it to send a message, then it queues something into the output queue, and if it's not already sending, it calls begin sending. So what is begin sending going to do? It's going to say message is equal to, why did that always say this in front of everything? Is that strictly necessary? I mean, that probably compiles, right? Let's comment that out and see. This is probably one of those style things. Method must have a return type. Oh, crikes. There we go. I've been doing a lot of stuff in TypeScript lately and Python and all kinds of languages. I constantly get confused about what sort of style I should be using. Let's say if I was using this there, then I should probably use it here. But I don't want to. Here I have to because those symbols have the same name. That makes sense. We'll make this client socket. And then we can say socket is the client socket. Presumably that doesn't break anything. Now we're in here. We don't need literally this. Oh, those two we don't need. Those we don't need. Just go ahead and do that. I'm sure that should probably still work except for that. Yeah. Oh yeah, forgot I have to comment that out. Yeah. Sometimes it displays bad file descriptor in the build output window, and sometimes it displays it in the console on the other side. Okay. Var message is equal to send out q dot, well, if that's out q, is the other one dq? Try dq. I don't want to try Dairy Queen. Methods. I guess you got to try it, huh? Tries to remove and return the object at the beginning of the concurrent queue. When this method returns, if the operation was successful, result contains the object removed. If no object was available, the value is unspecified. Oh, I see. It's an out. True if the element was removed. Oh, that's an irritating. If two threads call try to queue at precisely the same moment, neither operation is blocked. When a conflict is detected, one head is to try again to receive the next element. Yeah. If the method is successful, Okay, so I need an I protocol message, and then I can say if outq dot try dq of out message is equal to false, return. Okay. I imagine, that's getting old fast. Imagine in that case, okay, so we might say pull out a message to send. Now, if there are no more to send, then this does nothing and returns. But it did get a message if it gets here, so now we can say send buffer is equal to message dot encode, and bytes sent is equal to 0, and then it can start the operation to send that buffer to the remote end, and it's going to call send callback, which is going to get the state, it's going to get the socket, it's going to do that, it's going to send bytes. If client dot byte sent is equal to client send buffer length, then we know we've finished sending. So let's do this. Finished message transmission, and then we can say client dot send buffer is equal to null with the semicolon, and client dot bytes sent is equal to 0. And now we don't want an else here, we want to begin sending here. Trigger another send. Whoops, another, trigger another send. If this send was complete, then this will check and see if there's another message that we can send. But if this send was not complete, then we'll try to finish the job. Okay. I think that is all we need. Let's double check by coming over here. So what do we have that's different? Now here in the, let's turn that off for a second. No, can't do that, huh? Okay. Here in the introduction message where we used to get 3 bytes, we now have 4, and then there we go. We add an implicit length of 3 to the buffer at position 0. Starting at position 4, we put the 2 bytes for the introduction. At position 6, we put the protocol version. And over here, we do a similar thing. We now have 4 on the size that we send. The message length is the entire length of that buffer minus the 4 we just added, sending it to the buffer at position 0. Then the error. Oh, that's not right, is it? Oh, yeah, it is. This one's always 0. From position 0 in those bytes to message at position 4, because 0, 1, 2, and 3 are that one. 2 bytes, 4 plus 2 is 6, sending 4 bytes, 6 plus 4 is 10, 10 plus 4 is 14. So that's doing that. Now over here, the client has a concurrent queue that it creates. We cleaned up some code just to make the diff terrible. When you try to send, it queues a message, and if the send buffer is currently null, that means it's not trying to send something, then it calls begin sending. So in the initial case, that's what's happening. Begin sending gets called. That's down here. The first thing that we do is, this maybe needs to have some stuff on it too. Okay. Because begin sending is going to do that part. So yeah, okay. Ooh, this is why we trace through complicated code. Begin, well, not that one. If the buffer is null, we call begin sending. If the buffer is not null, we don't call begin sending, because if the buffer is not null, then there's already a send happening, and when the send is finished, it's going to implicitly pull this message out of the queue and go on. So that is cool. Down here, we want to say if send buffer is null, then do this. Did I just turn caps lock on? No, I did not. So if we're not sending anything yet, then pull a message to send. This will silently do nothing if there are no more messages to transmit. Okay, that's good. We'll rewrap that. Otherwise, we get down here. Now we know send buffer has been set to something. Could be the thing we just pulled out. Could be a partial send from before. Byte sent is either the 0 we just set it to or whatever it was before. The number of bytes to send are the length of the buffer minus the number of bytes we've already sent, which currently would be all of them. We don't care. We call send callback. And what happens in send callback? In send callback, we finish that particular send. We update the number of bytes sent with that the client has sent with the number this send operation transmitted. If the number of bytes sent is the length of the buffer, then we know we've sent everything, so we clear that so it's as if we aren't sending anything. And then we call begin sending. So what happens in this case? If this send didn't finish, then begin sending comes all the way back up here. This is not null, so it does nothing, and it continues the send coming back to send callback. When it gets back down here again, say it finishes that whole send, it sets that to null. Now it calls begin sending. It comes back up here again. One of two things can happen. It's going to get in here because send buffer is null. It's going to try and take a message out. If it doesn't get a message, then it just leaves. There's nothing more to transmit right now. If it does get a message, then it encodes it and does a begin send. Now, I think that should be fairly safe because the only thing that's putting messages into the queue is the read code, and that code is only putting stuff into the queue here when it knows it's not sending anything. There might be some slight race condition here, but for our purposes, I'm going to assume that this is what you might say good enough for government work, or close enough to win in a game of horseshoes. So we no longer need to worry about any of this stuff because it's just doing that now. So I'm going to build this like so, and then I'm going to run it. Now, oops, we're going to come back over. I'm just going to close that for the time being to network.py here. We're way down at the bottom. We don't need message to block anymore, and we don't really need test anymore. We are connecting to Dart at 50,000. So this is the same test code we had before, only now we might actually receive messages. So that's exciting. Let's see what happens. We finished sending and we finished sending, and over here we created a connection established. We received an introduction, and we received an error with this is an arbitrary message, go us, and then everything gracefully shut down and we threw away connection. Now notice the network thread is gracefully ending, which means it's gracefully closing that connection before it destroys the thread and does that, and both of those are the del, so that's them being cleaned up. So I think that means that in a mere 34 minutes we have managed to clean up this code base somewhat, excuse me, and have it what appears to be sending messages. Now, I suppose it behooves us to modify this slightly because when we call begin sending here, if we were to replace this with 1, then it's going to keep calling send on 1 byte. And we saw here that it sent 7 bytes and then it sent 56 bytes. It was sending both of those messages full on, which is what we want. So what happens if we do it and it sends the message back 1 byte at a time? Do we still get to see the messages? Over here, it's actually safe to reset this and go. And it received an introduction and it received an error. So that totally worked, although this scrolled way faster than it could keep up with. So that is Captain Fantastic is what that is. Now, maybe one last thing to test here is in send. We swap this and this around. This is what makes this send to the other side. So now this is the worst case scenario of the client sending messages one byte at a time. Um, and I realize, if anybody was curious, that it is entirely possible for the network subsystem to not just send in single bytes out. There's probably some sort of caching behind the scenes, that it doesn't want to send off a packet until it gets some data. But still, we want to. This is more for testing our ability to do partial stuff where we know there's a better chance that we're not getting all of the data all in one shot than anything. So if we do that here, now we're going to send it one byte at a time, and that is going to receive it one byte at a time and transmit it to us one byte at a time, all theoretical. What happens here? We received an introduction and received an error, and it still worked. So I'm going to call that all kinds of crazy success. So we're going to scoot that back that way, like so. Now the last thing that one wanted to do here is modify this a little bit so that in send, we don't encode it and then put it into a byte array and then do that. Let's say what we want to do is just say protocol message instance.encode here. And all of this part goes away. And in its place, over here in this code, we need to do an extra thing here. Now, I suppose if I had been paying more attention there, I would know that uppercase I is what we're throwing in there. So if I put an uppercase I there and say that the entire length of this particular operation is 3 bytes, like so, because 2 bytes for the message ID and 1 byte for that, then that is packing up this entire message just in one shot into the buffer. And the other one would be error message, where we struct pack. We have to add an I on there. Now, what are we returning here? We're 2 for the message ID, plus 4 for the error code, plus 4 for the bytes that the size of the actual message data that we're transmitting, plus the length of message data. So the 2 bytes that say this is an error message, the 4 bytes that say that this what the error code is, 4 bytes that say how big the error message is, and the bytes of the error message itself. And well, yeah, that's not going to do anything, is it? But with those changes in place, I should still be able to do that this way to, whoops, transmit data over. And ooh, that's unhappy. Do line 130. What did I do? Oh, I forgot to put a comma. That's what I forgot to do. Okay. As far as errors go, that's more scary than it needs to. So we still managed to transmit a message with protocol version 1, and that's what we got back, and we received that error message with an arbitrary error code, with an arbitrary error message. Technically, they're both arbitrary, but nevertheless. So we can go ahead here, and what do we want to do for changes here? I think we want to do the C# stuff first, or maybe we do it for all of them. So we we'll stage this one, and stage this one, and messages dot, whoops, I did not mean to do that. Messages dot py, we stage this one. And this one has to change because it does the same thing. So we're going to stage that one so that the only thing that's in is that. And then we say modify our message classes to encode their length. In order to make the send code more straightforward in the C# server code, and also in order to keep the client code working in a similar manner, the code for encoding a message into a byte array for sending to the other end of the connection is now responsible for also including the length prefix. The decoders still assume that they're being passed just the bytes for the message without the length prefix, since it's harder to read the minds of the system to figure out ahead of time how big the block should be allocated for reading the message data. And the last thing is our ability to transmit messages to the other side. And you know what we might actually do here just for extra tests before we submit that. If I come over here, I'm going to jump, well, we'll use this thingy here. It's just doing this a whole bunch of times with a little bit of sleep in the way, right? So if we looked at this and put it twice, then theoretically we should see the messages appear twice for each time one is sent. Oh, actually, before we do that, we should probably have, whoops, we probably want the begin sending to try to send as much as possible. Almost checked that in. That would have been terrible. Okay, I'm gonna run that. So in theory, we should see 2 introduction messages and 2 error messages because that thing is putting each one that it receives twice. So we'll see how terrible this is gonna go. Introduction, introduction, error, error. Now, that doesn't prove that there's not a threading issue, but it's not too bad. I mean, if we determine that there actually is some sort of problem, it's easy enough to add a mutex and lock access to that data or the client as a whole or something like that. So that's not the end of the world, and I don't want to do that just yet until I know for sure and do more research. Because many mutexes are not recursive unless you specifically create one, and that's a great way to blow your program up when you stupidly have the same thread lock the mutex twice, which is generally frowned upon due to that whole causing a deadlock thing. If that is actually using a thread, then that's okay. But if it's not using a thread, it's not okay. And if it sometimes uses a thread, then we probably want to bang our heads on a brick wall or something. So the remaining change is that we cleaned the code up a little bit. And also there's this new send method. And that code is cleaned up a little bit. We actually have code in begin sending that actually sends something. I guess we probably Don't want to do that twice per se. We might actually want to just say in message.getMessage here, and if this message is complete, then echo it back to the other end and get ready for another received message. We'll just double check that that is safe as anything else we've done, and it also seems to be working pretty good. So that is on the whole not too shabby. So let's jump back into here, and again we threw away all that stuff, so we don't care. I guess we are being told that messages are being sent, which is, at least for the time being, what we want to have happen. So let's go ahead and stage that and say add the ability for the server to send messages. This adds the necessary, I did it again, enhancements. I was working with something today, I can't remember what it was, where I tend to use the keyboard key for opening the context menu so I don't have to touch the mouse. And I had a spelling problem, and I hovered the mouse and hit that key, and because it was an Electron app, the menu that popped up wasn't a standard menu, it was a web menu, and it didn't have keyboard action, so I still had to use the mouse anyway, and I found it irritating. This adds the necessary enhancements to the build client class in the server so that it can transmit binary messages back to the client. For the time being, this is purely still doing an echo type operation and nothing else. Right? And commit. Now, we still have some time here, and I don't mind going a little bit later tonight than I might otherwise. Unless we have horrible problems. But this is a pretty good place to stop if we have to with only 3 commits. We've done a fair amount of stuff here, cleanup and otherwise. What I'd like to do is first come over here. Introduction message is 1. On the error message, sorry, the introduction protocol message is 0. Error message is 1. I'm going to pull this class here. And we're just going to call this message. This message is used to report generic message information to the remote end of the connection, like so. Now here, message is 1. We don't actually need an error code, and this can just be message, so that can go away, and self.message can be equal to message, it's ID 1. We decode it. We don't have the code, we just have that. We get the message type that we don't care about, and we get the message length out, like so. And then the message string is from that position. Should still work. And then we return, just to type anything, message with message stir and that. And if we were to encode this, it would be message, and we pack the length and that but not this one because there's no error code. So we're packing, there's got to be one fewer here. So encode the bytes. What are we sending? The 4 bytes that are the length of the message type, which is 2, the length of the message, which is 4, and then the actual bytes. And here's the 2 for the message. Um, oh, crunk. 2 for the message type plus. Oh yeah, this is the actual message body. That's right. The actual message body is the 2 bytes that are the thing that says that this is a message, the 4 bytes for the length of the message, and then the actual length of the message. And this is actually supposed to encode to message.message_id and not error message.message_id. That would be terrible. Otherwise, when you transmit a message, it would think it was a regular message and go away and cause all kinds of errors. And then that's one too many. And then error message needs to be 2 instead, but otherwise kosher. And over here, we're going to go to error dot this thing, and now the code for this is 2. So message type error, that's actually in the partial. So that's okay. So we actually want the factory here. We know that the error is 2 and message is 1. So if it's error message data and case message type dot message, return new message for the data. Now that's not going to compile because that class doesn't exist yet, but that's not too terrible. Just verify the message types are correct. The dispatching there is correct. For the actual error itself, nothing needed to change in this class because unlike the Python code, this one doesn't track that kind of information. And if I save as this as message, instead, I'm just going to close it and reopen it so that GitGutter knows it's new. We're going to find all instances of error message and replace it with, ooh, that might be something that we forgot over here. Is there a, there's not, huh? A thing to let us know exactly how that's supposed to look. Oh yeah, okay, we didn't do it that way, we did it over here. If it's an introduction message, we do it this way instead of doing it that way. So, okay. So, message has a code. No, it does not. It only has a message. So, that part's okay. This is just going to be message. That part goes away. Message is still going to be message. The data length is less than 10. It's not valid. Well, I think we'll find that the 10 was based on 4 plus 4 is 8 plus 2 is 10, but now it's only 6. Like so. So message data length is invalid. Code is starting at data at position 2 because we already know the type. The thing that called us knows that that's the data we're supposed to use. This could actually also verify that as an extra exception, but that's something to be done later. And the message length is at 4. The first 2 bytes are, yeah, the first 2 bytes are that. So And if we were to encode, we don't need this 4 here, like so. And we're not putting this in. So we're sending from 0 starting at 4. This is now 4 for 4. 4 and 2 is 8. 9, 10, 11, 12. And this is then 12. Message, shoot. I had that problem before, didn't I? Well, that's something to be fixed later. And there. Is that all of them? Nope. Is that all of them? Ooh, now it's unhappy. 19. Oh, yeah. Ah, 24. Oh, maybe that is not all of them. Message. Okay. Next. Code does not exist. Boy, I did not do a good job of knowing that. Just, oh, I see what I, no wonder that number did not seem right. That's 4 and 4. And that one becomes 8. Okay. Kosher? Almost. 44. Oh, yeah. Take that part out. I was looking right at that and still didn't join that up here. Okay. Now over here in the network code, actually make this smarter. Maybe we do that too. We're going to send an introduction message. We're going to con.send a message that says, I am the arbitrary message text. Thus, and I'm going to come over to here. And I'm guessing I probably want, we'll do it up here, let's say. Well, yeah, let's do it here. Return intro. Oh, let's do it the same as we did it over here, shall we? Introduction message version equals that. Oh, I think I actually want, oh yeah, no, I want to add string.format here. No, I don't. I'm doing the Python version. And what would we actually put here? Self.protocol version, I suppose. And let's copy that down to here, where it would just say message. And that's going to be message, like so. And here, this one. Oh man, I spelled that wrong. Why do I not notice these things? Introduction message. There we go. The error message is this. I could probably actually just zoop that like so as the entire contents of this string. And it'll just kind of work. Now, what do we actually put here? Self.error code and self dot error. Oh, no, not that one. That one. And we can jump down to the bottom of the network code. Oh, that's kind of, oh, I guess it's just that goes. Those are special, and those are special. Okay. Received. Okay. Now we're going to see some serious blowing upping. I'm going to build that to make sure that it is fully built. And we're going to kill it and restart it, and then come over to the terminal and see how terribly we broke things. This is why I love Git so much. We know it was in a working state, so it's easy enough to figure out what we changed to break it, or just to throw it away and not worry about it for right now. Message is not defined. Well, I guess that's probably because I didn't import it from that thing at the top. Did I call it message? I think I probably should have called it message because all the other ones. Okay, we'll keep that one. We'll skip that one and keep that one. And oh, like so. Well, I mean, it's terrible, but from messages import message, and error message, and way down here. I mentioned that the code that we work on for work, there's a class named message for sending a message to another, and it's in Objective-C. So there's a class method that you can call called message for message, which creates a message based on, basically it's a constructor, a keyword argument constructor, and that creates a new instance based on carrying a message payload, which in our system could be one of several different things, like feed data for the stock market. And that variable is almost invariably called message. So you end up seeing things like HBWF message equals message, and message connection message equals put message connection message for message. It's ridiculous. Okay, so that's still good, and let's give her a try, shall we? Okay, well, we blew that up, and one of these files is... Oh, why does this keep happening? This is irritating in the extreme. To a lesser degree, I'm kind of concerned why Git seems to display a message every time I run a .NET program, but that's neither here nor there. Message data length is invalid. Okay, so there's actually a problem here. 2 bytes for the, oh, it's 4 bytes. No, 2 bytes for the size, 4 bytes for the bytes, should be 6. Better change this to 1 and 2 so we can see which one of these is going wrong. Oh, actually, the problem is probably this. There's not a thing in front of it anymore. There we go. Finished transmission, finished transmission, finished transmission. And boy, that's a long timeout. Maybe we can get rid of that because we probably don't care anymore. Created a connection, error while receiving, unpack requires a buffer of 3 bytes. Oh, okay, so totally managed to break things pretty hardcore. Well, we received an introduction message version 1. So that's something. And just like that, what should have been a simple change is not a simple change. Let's just vet everything one more time. First of all, that's going to irritate the hell out of me if I don't do that. If you're going to decode it, then it's going to just have the 2 bytes that says what it is and that, which is 3. And here we're packing it and saying there's 3 bytes in the body, and the first one is the message ID, which is that hard-coded value, and then the protocol version. So that's unlikely to be the issue, one would assume. Now here, this one is also broken in an annoying fashion. Always be careful of copy pasting code because you end up copying and pasting something that's broken. And where that was 0, this is 1. Ow. We want the 2 bytes that tell us what kind of message this is, followed by the number of bytes in the message, which is the same as that. And we don't care about the type because it's there. And then the message string is unpacking message len bytes from the data starting there. Now, it really seemed like that was the issue with that one. 7 bytes is the right amount to send. And when we encode the 4 bytes that is the size of the message plus the 2 bytes that say what it is, plus a length, plus the actual bytes. So here's the length, which is the 2 bytes to know that it is a message, 4 bytes to know how big the string is, plus the length of the string. So that is 6 plus the length of the string, and there's the message ID, there's the length of the string, and there's the string, and we're registering message, and lastly, an error message. That one actually, let's say I copied it from there. Does that mean one of those other ones is broken? When we decode, we get the size of the code for the message, a code for the error code, and a code for the length. There's the code and the code for the length. When HII message stir is the return. And when we encode it, we need the 4 bytes for the length plus the 2 bytes to say that it's an error message plus the error code plus the length of the error message plus the bytes of the error message itself. So this is the length. It's 2 for the size, 4 for the code, 4 for the length of the string, and then the length of the string in bytes. Then the first thing is the message ID, then the error code, then the length of the message data, and the message data. So that really seems like it is probably kosher. So what weird error did we see here? Error while receiving, unpack requires a buffer of 3 bytes. That's confusing because a buffer of 3 bytes would indicate that it was an introduction message, which it successfully retrieved. So let's go ahead and restart that. As a matter of fact, we might also I probably could have just searched for star, 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 but not as a regex. I'm going to temporarily comment this out just to keep things sane. Okay, so let's just test this one at a time. We're going to comment out both of those, like so. And we're going to open that up. Now, let's run it. Oh, fudge. We want this one. Okay. Received introduction message version 1. Good. That's what we expected to have happen, right? So good. And it gracefully went away. Now let us send a message instead. Unpack requires a buffer of 3 bytes. Okay, so there's the issue. The issue is in message. What idiotic thing did we do here? I bet you the idiotic thing we did here. Message ID is 1 there. It's 0 there. It's 2 there. Did we do it wrong over here? Yeah, we did. When we encode a message, we're not putting the actual bytes for that thing in. Oh, good gravy. How did that slip by? Okay. If we were encoding in this message, uint, that's the length of the thing, message type introduction. So yeah, the problem here is that part's not in here. Let's copy that. Really boned that one up. I think I took out one too many. First, we're going to send the length of the message, which is up there. Okay. Trace it through. The bytes of the message are the actual message string encoded as UTF-8, and we capture the length, and we create a buffer that has those bytes plus 4 to know how long it is, plus 2 to know that this is a regular message, plus 4 for the length at the beginning. So the first thing is the length at the beginning, which is the length of that buffer minus the 4 bytes that we added to hold this field. The next thing is message type message, starting at 0. Now, if this goes at 0 for 4, this goes at 4 for 2. And then the next thing is the length of the message, which is at 6 for 4 bytes. And then this becomes 10 for message length. Okay, that is built, that is running, and when we try to send a message, we get a received message version equals I'm an arbitrary message text. Okay, so that clearly could be fixed on this end to not be so idiotic. Message equals, and this should be wrapped like so. But all else being equal, that is more or less what we want it to do. Received a message, I am the arbitrary message text, which is good. And as our final test, we should look in the correct file and, well, the second to last test and do this. And now when we run it, received an error message, and now we can do that. Wait for this to time out and go again, and now we can see we received a message, introduction message, and an error message. Oh, I guess that should say message, shouldn't it? Maybe these should just say their other thing. I mean, this is the nitpickiest of nitpicks, right? So let's see what we got here. We'll say that this is actually an introduction of that version, and this is a message of that version, and this is an error for that version, like so. And over here, that just says message, and that just says introduction message, so it should say just introduction. And we'll save it, and this one should say error, like so. And it does, and we're going to build and try it one more time and check it in. Stop, start, and come over to the terminal, and we received an introduction of version 1, a message of I am the arbitrary message text, and an error with code blah that says this is an arbitrary error message. That stuff said that over there. So what all did we change in this giant pile? We added a new message is what we did here. Okay, so these are all, well, to some degree related to that. So we're going to stage this hunk and this hunk and this hunk. And over here, we're going to stage all of this. And in Protocol Message Factory, we very clearly have to stage that part or it's going to be unhappy. We added a new message type, so we should stage that. And here, we're going to leave all of this stuff out of this commit and then say include a third message type for regular messages. This is just, okay, this includes a new message type that's like an error message, but which has no error code because it's just a message. In theory, this could be just a single class, and we could determine if this was an error or not based on whether the code was 0, but I like the idea of having a distinct message for that instead. And that is nicely committed. And the last thing here is I'm going to discard this hunk to put that back for the time being. But what we do want is this stuff here. So I'm going to stage this and then say include tests using the new message classes. This extends our test bed code so that we can see all of our message types being echoed back to us. This also leverages the new methods that were added to make debugging nicer. And away we go. Now, could just call it here, but what I'd like to try to do, I don't know how well this is going to work. Now, this is all the stuff in net test, right? So we're going to minimize all of that for the time being. And here's what we're going to do here. These two over here are the ones in net test, as we can see over there in the sidebar. I'm going to temporarily close all of these files like so. And in this level, I'm going to open messages and network like so. Now, this is the Devember one. This is the one that was originally, excuse me. This is probably very similar to this one, except that we added a new message type. So we're going to copy that, and I'm just going to verify. Yeah, so we're going to paste that over here and save it. And Sublime successfully loaded it, so we can close that one to make that nicer. Now, here is where things start to get interesting. If I was to compare compare this to view, and the view is network, what is different besides everything? Where we get messages from, we don't need the log, and otherwise everything is more or less just implemented in a way that it wasn't before. Okay, so that's good, one would say. So, yeah, this is Sublimerge, by the way, which I highly recommend. I used to use it a lot more. My Git before merge came out, my Git workflow was to use the regular Git package to add files one at a time and to do this keyboard shortcut to tell me if a file had changed or not and use that to diff them. But now I do everything in merge instead. So if that's what the code looks like there, that's what it looks like here. We definitely don't want, okay, we definitely need those. I'm going to say we want to pull all of these out to here, thusly. That's still okay. Now we want to get messages from dot messages. We're going to copy both of those and paste it here and throw a, whoops, dot in front of those so that it pulls them from their correct place. From test client, get log, so we don't have to have the log method here, which is good. So we don't want that, but this has connection manager and connection and that. So we want to start here. As a matter of fact, let's do it this way. We want the connection manager class. We want the connection class. We want the network thread. These are the parts of this that we definitely want, including that. And if we were to look over here, there's connection manager, there's connection, there's network thread. So those are all those things that I just put there, and we can plomp that down like so and do that. Now, here's where things get interesting. This is something we don't actually need anymore. So we can go ahead and get rid of that. Now, this actually is in the Sublime plugin directory. So what we want, whoa, and clear that one. To def plugin loaded. We're going to say, oh, I guess we need another one of these. Oh, and again with that, sometimes that auto comment continuation thing is a bummer. Well, let's say manager is equal to none, like so. And when we load a plugin, what that is the point where we'll say message is equal to, actually there's no reason not to just create a connection manager there, right? We'll do it this way. The manager, oops, that should be, manager is the connection manager. So our global connection manager object. When the plugin is loaded, say manager dot startup, which fires up the network thread and gets it running. And when we say def plugin unloaded, then we say manager dot shutdown, which is what we were doing over here. This is the one test that we did, but we're connection managering, we're starting it up, and then we are sending a message to the other side, and then we are saying manager shutdown at the end. So that by itself should be enough. Once we save this, we see the thread, the thing being spammed like nuts with that. So let us search again for star, 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 and not that one, not that one, that one. This is not something that we need for right now. But now I have to quit and restart to get that out of there. Creating network thread. So now it's quietly not harassing us, right? Now, if we go down here to test client, this is our original client that was doing stuff, right? Actually, I suppose what we want here is, whoops, in test client, we don't want to do that or that realistically. We don't need a job queue and we don't need a job thread. What we do need is a manager. And we might actually say that up here. I don't know how well this is going to work. From dot network import manager. And let's go ahead and print manager. Boy, brain really wants to type that. And oh, it is very unhappy now. What have I done in test client? Huh. Well, let me tell you what I was expecting, and the answer is not that. So you're saying if I save it again, it's still broken. If I uncomment these, or if I comment those, huh? All right. Well, we'll just leave that alone for the time being. We're also going to remove, say, all of this stuff. We absolutely don't want plugin loaded and plugin unloaded in here either, because we got that somewhere else. We do still need the log code. That's where all our logging happens. Do we need this network thread? No, we are no longer using this network thread. We definitely don't need this version of the protocol message class, so we clean that up too. And socket test command as an application command is here. So realistically, what a person might do is pull that out. Just for the time being, leave that there. Come over to here. Throw all the way down to the bottom. Thus. And I need another one of these. Now this stream is going on to an hour and a half here, but I wanted to get a little something interesting done here. Now we're going to change this from an application command to a window command. Thus. And what's the init on a window command? If I had to guess, it would be thus. Now it's unhappy here at line 23. Oh, does this sort of stuff have to be, it has to be at the bottom? Is that why that wasn't working before? Well, you know, live and learn. I guess we actually would say manager equals none, and then we can say global manager equals connection manager. Yeah, we'll do that. I removed that from here and I didn't technically need to, right? Let's bring it back in that case. Let's bring it back from there. We're going to leave, we're going to set this to none. Again, that's going to get the global manager, create it, and it can shut it down from there. That ought to be fine, one would imagine. And we'll jump back down to here where we were doing something and just grab this command because we did kind of change things a little bit. Clean that up, come back to test client and paste it here. Oops, I went too far. There we go. So there we go. But this is not a comment that makes sense anymore. Building and destroying a lot of things. There's the message. So if that's the appropriate init for that, and you know what? Something messages.py. Seriously, why is this thing constantly flipping this thing? I don't know what I'm doing to do that, but it is irritating as all get out. Okay. Again, let's do that again. And we cd to home local sublime text 3, and we subl, I can't remember which it wants. Window command. Look at that, self window. I am some sort of semi guy that remembers things. Okay, so there we go for that, and then we can say self dot connection is equal to none. So here's what we're going to do. We're not going to job queue put. We're going to say if self dot connection is none, then self dot connection equals manager dot. How does this work again? Okay, we're going to remove this because now we know that we pulled that part out. And we'll leave that there for the time being to remind us of other things that we want to do. And introduction, connect to Dart on port 50,000. And then self.connection.send a message constructed from message. Send message. Now we're not going to be able to see a return on that. And my nose desperately wants to sneeze. I have a feeling I may have orphaned something. Nope, I didn't. Cool. CD remote build server .NET run. Here we are running our little server, and let's see what happens when I push super T. It's asking me for a message. I'll say, is this working? I'm willing to bet probably not. And I hit enter, and global name manager is not. Oh yeah, I guess I probably have to actually import the thing, huh? From .network import manager. Okay, let's try that again. Attempt 2. Global name message. Oh, hey, you know what I should probably also include? This. We're getting there. We are getting there. Okay. And I'm going to go. Is the third time the charm? That says, oh, sorry, that's the console. It totally sent the message to us. So all we need to do now is figure out a way to get the connection out of it. Note that it has, it had one in the out queue. So this is a somewhat of an issue because we don't have a way to trigger some sort of notification. We might say this, def print result. If self dot connection. No, we don't even need to do that. This is going to be the simplest of simple tests. So we're going to say sublime dot set timeout for a lambda. And the lambda is going to be self dot print result. Well, we'll just say result. What the hell? And this will be result. And message equals self dot connection dot receive. If message is not none, then what used to be in this thing? Up in the network thread, this code here called that. Log received with that business there. So we're going to copy that and quit. And I think we're going to see some action here. Oh, man. I accidentally did something I didn't want to do. Log message dot message. I can't remember what it's actually called. It's message. Okay. Log, well, let's do this. Received /n that dot, no, we don't need to do that. We can just do message and dialog equals true. Okay. Now we're ready for something maybe. Fingers are crossed. We hit enter. Connection object is not callable. Of course the connection object is not callable. I swear. Well, okay, we got to save that, destroy stuff, and whoop. No, we don't need to do that. We need to do this. Arg. Oh, you know what? I should probably have added a timeout here. Alrighty. Yay! 500th time's the charm. I am a message that is, for some reason, being sent and echoed in a stupid binary fashion. Yay! Only works one time, huh? Not gonna lie, I'm a little cheesed by that, but we totally saw it happen. It doesn't look like it's actually, oh, because that's supposed to be there. It only needs to create the connection one time. It doesn't need to only send it when it connects. Okay. You know what sucks? Typing in long connection test messages when your code is broken. Well, let's say borked. Hopefully it works a second time now. Weehaw! Okay. We have that, we have that, we have that. We have me saying an hour and 38 minutes. We have actually done some good work here. We have some sort of system set up by which we can create messages here and transmit them to the opposite end. Now, clearly what's missing here is the ability to register with your connection that you want to have an event handler trigger to let you know that you actually received a response. You don't want to use a set timeout result like this. So that's one thing we need to do before we proceed, but I think that will be fairly simple to do once we decide on how we want it to go. So I'm going to say that we call the stream here because I am quite tired and I still have to create a blog, and it's actually 10 o'clock, which is the sad maker. And tomorrow, planning shall commence on how we want the build to work. Now, I said before that I have ideas for how this is going to work, and I still have those ideas in my head, but what I'm going to do is sit down in the stream and work out exactly how I want this all to interact and see if I can find any flaws, because I've never actually written it down. So expect the stream tomorrow to be not much code and heavy on design type action. But that is all I have for right now. So I would like to provide a hearty thanks for hanging around on our Devember project, and we're getting some exciting results. So until Devember day 11th, this is ODAT Nerd saying, have a sublime day.